Hey guys, today I'm going to be telling you about some important thermochemistry concepts and formulas. The first section is work. Work is the application of energy from one part of a system to another, or from one system to another. Energy can be thought of as the ability to do work. Both work and energy are measured in the SI-derived unit, the joule, which in base SI units is kilogram meter squared per second squared, since the kinetic energy formula is 1/2 mv squared. So that gives us the kilogram meter squared per second squared unit. Then their formulas are pressure volume work is when a pressure and a change in volume come into play. So the work that is applied on the system is the pressure of the gas, is the negative pressure of the gas after the work has been done, multiplied by the change in volume of the gas. Then force distance work is simply the negative force times the distance that is traveled, or the distance over which that force is applied, which basically the negative sign means that you have to put a force on something for it to move. Here you can see that the change in energy is the change in thermal energy, which is just a shorthand for any other change in energy, excluding potential energy, minus the work done by the system, not on the system. Reaction enthalpy is the energy released, meaning chemical potential energy is converted to thermal energy by 1 unit of a chemical reaction. For example, 1 unit of the reaction between water and oxygen is 1 mole of oxygen plus 2 moles of hydrogen gas comes to 2 moles of water. Since this is a reaction of just elements in their standard states converting to a compound, just divide the energy released by 2 and you get the enthalpy of formation for water. In chemistry, an exothermic reaction is marked as having a negative enthalpy change. This is because there is a loss of chemical potential energy even if the thermodynamic system gains thermal energy. Basically, what that means is you can take the enthalpies of all of the products summed up. If there's 2 moles of a product, you just put 2 of them in, minus the sum of all of the enthalpies of formations of all of the reactants. Once again, if there is more than 1 mole of a certain reactant, you just multiply it by whatever number. Reaction enthalpy is marked as negative when dealing with a release in energy because potential energy, also known as mass, is converted to thermal energy. Yes, mc squared is applied in chemistry sometimes. An attractive force like gravity has negative potential energy. This denotes that mass, potential energy, is converted into kinetic energy. A repulsive force has positive potential energy because it takes energy to move the objects closer together, which is converted into potential energy, mass. Heat and temperature should never be confused. Temperature usually refers to the energy per particle in a system, whereas heat refers to the total thermal energy or change in thermal energy. If potential energy is mass, then why is it measured in joules? Because, of course, mass and energy can be converted between each other, and potential energy is just saying what happens when this mass is converted into energy, this specific mass. And fundamental particles do actually get their mass from trapped energy. And you'll know this if you have ever heard of antimatter-matter annihilation, because when matter and antimatter touch each other, they annihilate and release the trapped energy. Entropy is the concept of disorder in a system, but it is not that simple. What it really refers to is the natural logarithm of the number of different states a closed system can be in without a change in the system, multiplied by the kinetic energy of one particle of an ideal gas at 1 degree Kelvin, also known as the Boltzmann constant. The entropy change of a system and the entropy change of everything else always adds up to more than 0. In other words, entropy can decrease locally but not universally. Formulas. Entropy equals the Boltzmann constant times the natural log of the number of states a system can be in. The entropy of a reaction is the molar entropies of the products minus the molar entropies of the reactants. The standard molar entropy of a compound is the entropy contained by 1 mole of the substance in its standard state. So oxygen is gas. It never changes. You can't change it just by altering the state of the system. You have to do a chemical change or a change in the substance itself. That's why you need to differentiate between standard molar entropy and just entropy in a normal sense. A spontaneous chemical process, or any spontaneous process in general, is a process that once started will happen without any external input to the system. An example is something like a ball rolling down a hill, or hydrogen reacting with oxygen or fluorine at ambient temperature. When a process is spontaneous, the enthalpy change minus the temperature times the entropy change of an interaction is less than 0. If a reaction produces enthalpy, then dH is negative. If it produces entropy, then ds is negative. Temperature here denotes the temperature before the reaction starts rather than after, because oftentimes reactions, once they get going, they can make themselves spontaneous even if they require input. Then, a chemical equilibrium is a chemical system where the reaction and its reverse are both spontaneous and happen at the same rate, and therefore the concentration of the reactants and products will not change. An example is a solution, where the concentrations of the dissociated parts of a molecule and the concentrations of the undissociated full molecules remain the same unless the system is opened and changed in some way. Formulas. A dissociation constant can be calculated by multiplying the concentrations of all of the dissociated parts of a molecule divided by the concentration of the undissociated full molecule. Of course, if the stoichiometric coefficient is, say, 2 for something like the chloride in calcium chloride, you will of course raise it to the second power because you're just multiplying it twice because there's 2 of said dissociated part in the solution. And I would like to note that if the equilibrium constant of a solution or of a particular group of ions in a solution is more than the equilibrium constant of a fully saturated solution of those ions, then it will start precipitating out. And here you can see that the acid dissociation constant and base dissociation constant are just dissociation constants for acids and bases.
Yeah, no shit, Sherlock!